everybody, welcome back to the Math Dojo. I just wanted to say hi, make sure everybody was doing okay. We really miss you guys. I know everyone misses being at school, at work, but we're getting through this together. Today we are going to be doing a 7th grade lesson on solving problems with inequalities. Okay, inequalities we started learning in elementary school. And inequality are those weird alligator signs like greater than, less than, equal to, greater than or equal to, less than or equal to. So those are inequalities. And now that we're in middle school, we have these longer expressions with variables and unknowns and all of these properties that we have to use with the inequalities. So there are a few rules, new rules that we need to know. And we're going to dive right into it. Okay. Every year I get a lot of confusion on which one is greater than and which one is less than and how the heck do we know? Okay, there's a very simple strategy and a little secret tip that I like to use. But if you don't understand, please rewind and watch it again. The more we hear it, the more it sticks in our brain. The more we hear it, the more we hear it, the more we hear it, the more it sticks in our brain. So I promise you, you will get it by the end of this video. Solving problems with inequalities, let's jump right in it. All right, so first I want to go over the symbols. Okay, so I have this symbol here, which is the greater than symbol, and I told you before, why is it greater than? Why is this one this way greater than, and this one this way less than? And it's a pretty simple reason why. The reason why, think of the way we read. Okay, when we read, we don't read up and down, right? We don't read right to left. We read starting from the left, going to the right. So the same way we read a book is the same way we read an equation or an expression. So if we have the number 5 is greater than, because remember whatever the open part, this is called the open part, this is called the closed part because it comes to a point. So whichever the open part is facing, it wants to eat the bigger number, right? So the open part is greater than, right, is how we read this symbol. So 5 is greater than 1. Okay, so that's a simple expression. We can also do, since we're in middle school, we'll see more problems like this. 1/2 r is less than 12. Okay, and then of course we would have to eventually solve for that r. So what this says is 1/2 times r is less than 12. If we add part of the equal sign to the bottom of that less than inequality symbol, we now read this as less than or equal to. Okay, same thing from the greater than symbol, greater than or equal to, and we add this little half of the equal sign on the bottom of that inequality sign. So this reads 5 is greater than or equal to 1. Okay, and then 1/2 r is less than or equal to 12. These actually do play a role, the greater than or equal to or less than or equal to, when we're doing number lines, and we're going to get into that when we're further along in this lesson. But for now, this is the way we write an inequality and how we say the inequality, and now we're going to get to solving the inequalities. All right, so we have here 2s, or 2 times s, minus 5 is greater than 1. And what we're going to do here is the same way we would solve an equation. Okay, an equation is an expression with an equal sign. So the same way we would solve an equation is the way that we are going to tackle this inequality. Okay, so the first thing, your goal is to get this s by itself. So this term 2s, I'm leaving to the last step. So I want to take this minus 5 here and move it to the other side of the inequality sign. All right, so we're going to add 5 because we're taking the inverse operation. Okay, that will cancel, and what we do to one side, we have to balance the equation to do on the other side. So what I'm going to get left on this side, okay, so again, our inequality lines up and we have the greater than symbol still. So we're left with 2s on the left side, and 1 plus 5 is 6, okay? So now we have 2s is greater than 6. Again, I'm going to add my inequality down here because the next thing I want to do is get s by itself. So 2 times s, the inverse of multiplication is division. So if I divide both sides by 2, okay, that will cancel out to be 1. 2 over 2 is 1s, okay, is greater than 6 divided by 2 would give me 3. So with this problem, I was looking to solve for s. So s is greater than 3. So that means that s is not 3. That means s has to start with 4 or more. Okay, how we would show that on a number line. So here's where the inequality sign plays a part when we're graphing, because if I had s is greater than or equal to, I can include 3. But since s is greater than 3, I have to just start with 3. So I'm going to mark it with an open circle. If it was greater than or equal to, this would be a closed, filled in circle, okay? But if it's just greater than, I'm just going to mark it where I'm starting, okay? And then filling in the rest of the side that it is. So it's greater than, so of course my numbers are getting bigger. So that means my solution can be any number and ongoing. Okay, so now we're going to get into a real world problem, because we're always asking, how can we use this in real life? Well, we do use this in real life more than what we know. We're going to take a look at a cell phone bill. We can use inequalities to see, okay, if we want to spend only this much money, how much data can we use? Let's jump right into it. The plan comes with 10 gigabytes of shared data and costs $80 a month. Each additional data usage, for additional data usage, it's billed $15 per 1 gigabyte extra. So they're asking how many additional gigabytes of data, which we're going to use for D, the additional gigabytes, the family could use. So this is the equation that they came up with. Because the bill is $80 flat fee, okay, we're adding a one-time fee of $80, okay? We're adding together the $15 times however many additional data or additional gigabytes. Remember, the additional gigabytes we're representing with D. So all of this added together has to be less than or equal to 125, because they said they only want to spend $125, but they could spend exactly $125. So that's why we include the equal sign. Okay, so if we're going to solve for D in this situation, okay, what we have to do is we have to get the 80 on the other side. So here I'm going to subtract 80, okay? And what we do to one side, we're going to do to the other side, okay? So these two will essentially cancel out, and on this side I'm left with 15. D is less than or equal to, and 125 minus 80, we have 5 minus 0 is 5. We can't do 2 minus 8, but we can regroup, and we can do 12 minus 8, which is 4. Okay, so now we have 15D, which we're going to divide both sides by 15 so that we can get D by itself. Okay, and now we have D is less than, or it has to be less than or equal to 3. So that means that the Reese family, on their plan, they get 10 gigabytes of data and they can use 3 additional gigabytes at this price, $15 a piece, right? In order to stay in that $125 or less cap that they want to spend on their plan a month. So if we go and plug in this 3 for our D in the original equation, let's see what happens. 15 times 3 would be 45, right? So 80 plus 45, 0 plus 5 is 5, and 8 plus 4 is 12. So this is exactly 125, exactly what they want to spend, right? So we have to say to ourselves, is 125 less than or equal to 125? And if this statement is true, then yes, then this 3 is a solution to the problem. So the solution of D could be 3, it could be 2, or it could be 1. And the way that we graph this, okay, if we had 1, 2, 3, okay, we said that it could be less than or equal to, right? So if it's equal to, we're including the 3. And when we include the number, if it's equal to, we have to close the circle because this is an answer choice. And then less than goes to the left, okay? And anything that's in there, continuing, right, is an answer choice. So 1 could be a solution, -5 could be a solution, -10 could be a solution. Any of these could be a solution, okay? So there's many examples of ways that we can use inequalities in real life. Let's jump right into it. All right, so now we have this problem here where it says you want your total score to be 100 points or more after your next turn in a trivia game. So the goal is 100 points or more, okay? Each correct answer is worth 5 points, okay? Each correct answer is worth 5 points. If you already have 45 points, so there's your starting point again, because you already have 45 points, how many more trivia questions could you answer correctly so that your score is 100 points or more? So we're going to take 45 plus 5c is greater than or equal to 100, okay? And here is where the math comes in. So again, we're going to leave this 5c alone for now, and we're going to subtract the 45 from both sides. Okay, that's where these will cancel, and we're left with 5c on the left side is greater than or equal to 100 minus 45 will give us 55. Okay, so now I have 5c is greater than or equal to 55. Okay, so I'm going to divide both sides by 5 because I want to get 1c. Okay, is greater than or equal to, and what I do to one side I have to do to the other. What is 55 divided by 5? You are correct. It is. So c would have to be either greater than 11 or would have to be equal to 11. So that means I could get 11 more problems correct to get 100, or I can get 12 more problems correct, 13 more problems correct, 14 more problems correct. Any number greater than 11 will get me over my asking point here, or my wishing point. Okay? So I hope that this was informative. I hope you guys learned something from this. One thing that I want you guys to remember and to take away is the graphing part. So remember, when you graph, a greater than or equal to, you have to include that solid point. So you have to include the number and everything greater than. If it's just greater than, it doesn't include the number. So it is just an open circle in the graph. So that is one takeaway that I really want you guys to remember. And if you don't remember, please rewind the video to that spot and watch it again. Or rewind the video to the example and go through the example one more time. So I've received a lot of your guys' feedback. I've heard a lot of your comments on Class Dojo. If you guys do have any topics or any strategies that you need help with, please comment down below and I will make sure that that is the next video that we put out. We really do miss you guys and we want to see you soon. I know everybody is waiting at home, waiting for this to go away, but please do our parts. Stay away from big crowds, stay safe, keep everyone in your family safe, and we will see you when we see you. Keep up the good work, keep up the hard work, and I will see you. Bye.